Alright, so now we're going to talk about measures of angles. There are two different ways in which we can measure an angle, or two different units, I should say, in which we can measure an angle. Does anyone know of one of them? Excellent. Degrees. Very good. So most of us are probably familiar with degrees. You know, we hear them if you are into any sort of sports where there's spinning involved, like a 360 is 360 degrees, or a 180 is 180 degrees. It's a half of turn, whereas a 360 is a full turn. Most of us are pretty familiar with that, hopefully. And then the new measure that we're going to be talking about a lot is radians. So, before we get a little bit more into radians, let's talk more about circles, because circles help us with understanding angles. So, what is the equation for the circumference of a circle? Anyone know that? Very good. Excellent. So we know circumference equals 2 pi r, or sometimes we say circumference is pi d. Same thing, doesn't matter. But think about if I was to rearrange this equation right here, and I just divide by r, I get c over r equals 2 pi. Now why did I do that? Great question. I did that because this is going to help us understand that 2 pi radians is a complete circle, just like 360 degrees is a complete circle. So 360 degrees is a complete circle. But the 2 pi, so the 2 pi radians, is coming from this relationship right here. Now, another thing I want to back up a second. So keep in mind, the number 2 is the number 2, but also pi is a number as well. And so when we say 2 pi radians is a complete circle, well, 2 pi is actually a number. We just don't write out the decimal equivalent because pi is what we call an irrational number, so it's a non-repeating infinite decimal. And so it's a lot just cleaner and nicer if we leave it in terms of 2 pi. But we want to keep in mind that it's a number, right? We can type that into our calculator. It's approximately 6.28 something, but that's what this represents. Now, again, this further leads to our definition of radians. And so notice that c is the circumference divided by r, which is the radius, and then this equals an angle, which is 2 pi radians. And so generically, we have the relationship, what we call s over r equals theta, where s is what we call the arc length. Sorry, I messed up. So here we have arc length. And keep in mind that when we're using the word arc length, the circumference is an arc length. The circumference is an arc length that's a complete circle, right? But we can have arcs that are not complete circles. R is the radius. And then theta is the central angle in radians, and it has to be in radians. So anytime you use this equation, if you're finding a central angle, it is in radians. If you are trying to use this equation to find an arc length or a radius, and you are given an angle in degrees, you're going to have to convert it to radians, which we're going to talk about here in a second. And also, understanding this relationship of arc length over radius equals central angle helps us understand what 1 radian really is. So 1 radian, right, and when I say 1, like the size, how big is 1 radian? 1 radian is equivalent to an arc length divided by the same length radius. That should make sense because anytime I divide two things that are the same, I get 1, right? So if the arc length and the radius are the same, then the central angle is 1 radian. Now, we're going to see in a minute how big is 1 radian.